Okay, cool. So my name is Brent. I was working on a project to basically explore how one would use zero knowledge proofs and snarky.js to present verifiable credentials. I'm going to explain what all that means. A little bit about me. I'm sort of like I have a long tech background and I'm kind of a generalist, but my EVM experience is like only about 2 years. And I really only had basic familiarity with zero knowledge stuff before this program. So I'm going to walk you through like verifiable credentials, what they are, and then how one might mix zero knowledge ideas, proof ideas with verifiable credentials, also known as VCs. I'll show you my simple implementation and then I'll do a demo. So what are verifiable credentials? Well, what's a credential in the first place? If you think about it, typically in our world, a credential is something that is issued by like a trusted authority, right? So it'd be like your diploma or your driver's license, and it's something that shows it conveys information about you, about your identity or something you've accomplished or whatnot. But in reality, like a credential could be a lot more, right? And that's really where like standardizing it kind of gets interesting. You could have credentials about, digital assets. You could have credentials around accomplishments that are informal. You could have credentials around like your astrological sign, whatever you want. It's like I think what's interesting about verifiable credentials is it sort of like quote democratizes issuance of credentials. So verifiable credentials are essentially a way to like pack up in a standard format information about a subject, and then give it to the subject, and the subject becomes a holder, kind of like how you hold an ID or some other credential. And then that holder can then go and present it to somebody who can then verify it. And it's interesting because if you think about today, like there's a big world of identities. Like identities are really like shifting in the online space. Like you have kind of like your anon or semi-anon or pseudo-anon. You might be professional versus personal, on-chain, off-chain identities, etc. And so there's a whole world that's opened up by this. It is a W3 standard. It's quite something as a standard. It's like there's a lot to it, but the gist is that if you wanted to just like boil it down, it's essentially a blob of JSON that follows a certain schema, and there's certain elements to it. And I'm going to kind of, can you all see my mouse? Yes, yes. Okay. So the main point of it is like there's an issuer, and that uses a certain ID format, and then there's a notion of a subject, and the subject is kind of where all the meat is. Like, in this case, it's sort of like this person is an alumni of this university. And then there's this notion of there's like a proof area, which may be more just a set of signatures, but it's something that proves that there's a certain type to it, and there's certain other fields that depend on the type. But the point of it is that you can, as a receiver of this, you can go verify it. Okay, so you can kind of see where this is going, right? Like, oh, and then you can present it. I'm not going to get into this, but you can kind of see where this is going. So like, starting with the issuer issues the credential to the holder, and then the holder presents it to the verifier, and then the verifier goes and checks, oh, is this valid, right? So like, what's interesting I think you see this a lot with zero knowledge applications is like you can get rid of one of the sides of the triangle, because you can verify without actually going back to the original party, because the proof kind of carries through the verification. So let's talk a little bit about how we would apply this. And by the way, I'm not looking at you all because I'm looking at my screen. So if you have a question, just say something. Okay, cool. So there is actually a section on zero knowledge in the spec, and it's still a bit like speculative about how it would work, but they do give some examples. Basic idea is the way that an issuer would set up a proof would be something that is sort of compatible with a zero knowledge system, and then the way it would be presented would be compatible. I kind of boiled this down into like more of a toy. and I'll show you what I did. So let's take a use case that's like super fake and simple. If I'm like a wizard or something, and I want to show like how good a wizard I am, then I might want to show, that I met some training requirement. But I don't want to show how much I worked on it, nor the hours that I worked on it. It's kind of classic zero knowledge kind of situation. So maybe this training program provided me a verifiable credential, and then I'm going to present it, but I don't want to present anything other than just the fact that I meet the criteria, not the specifics, right? So if you kind of turn that into this use case, it's like, well, the holder, which is like me as the wizard, needs to present some proof that the first number that I have that was issued by this issuer is greater than or equal to the second number that also issued by this issuer, and it was all in a bundle. So like, if you take a look at like how it might be, like this is without a proof attached, but you'd say like, oh, like the credential subject has some sort of ID, and then it has this, and IDs, by the way, are decentralized identifiers, which I didn't dig into because it's just a whole other standard. But it has certain data associated with it, and this subject is what we're going to kind of make proofs around. So I focused only on the credential subject, and I decided to just treat the IDs as sort of scoped to Mina only, and we're gonna it's only using the Mina public key. So tests are things like, oh, it just needs to validate with certain inputs. So you can see like, 100 versus 99, and then versus 99 versus 100. And then the implementation is like pretty trivial. It's essentially taking, I kind of cheated by passing in the holder private key because I was still getting RO to do signatures, but it takes in like these things, including like the actual data and then the signed version of the data. And then it essentially verifies that the signature matches the data as expected. And then so once that's asserted, then it asserts that one is greater than the other and then emits an event. So let me do a demo. I'll try to do this fast. Okay. I'm going to leave the console open because it will show random things happening. So here's like over on the left is the unsigned like credential. And you can put anything in here. I'm going to leave 199, but I don't know what will happen if I do it something different. It should work, but who knows? And it'll generate these different sort of signed versions. So you can see now here's the credential set. Here's the proof, and I just made up my own type, snarky credential verification, and it has its signature in here, credential subject. And it's signed by this private key, this issuer. So this is kind of like, as an issuer, I'm issuing this credential. So I'm going to take this and I'm the holder now. So as a holder, I guess I could have done this in production, but oh well. All right. So I'm going to sign in. And it's going to do all this stuff on the right here. By the way, I'm really impressed with whoever developed all the worker stuff. There's a lot of complexity there to kind of work through. Oops. All right. Okay, I'm going to go to the production site. Okay, so watch me dead demo gremlins, right? Okay. Okay. So you can see these are the fields. And here's what it's doing. This is really slow because I'm on an M1, but it's going to be compiling the app, and this is what's going to be submitted. So let's compile for a second, and this is all going to hit Berkeley. Did anyone figure out how to? There's like a patch suggested to make the M1 faster.
I believe yeah, it hasn't been released yet from what I understand. I know it's done, but it's going through code review.
Yeah.
Yeah. And yeah, Jack was the one who worked on it. But yeah, I feel like we've been saying that for like the last 3 weeks. So sorry.
Well, now you can see the effects of it. Like it takes a while. I was also, oh, here we go. So now presentation is ready. And in fact, I've locally verified it. So now I'm going to present it. It's going to now create the proof, which is also slow. So sorry, everybody gets to painfully sit and watch the proof get created. But the point is, it's like essentially this is all happening in the worker, kind of following that tutorial 4, but kind of modified for this contract. And that's it. I think that's really all I have to show today, but it does actually submit it and it successfully verifies and emits the event.
I have a quick question while we're waiting. Underneath proof, it says type snarky credentials verification. What do you mean by type? Is that like TypeScript type?
Oh, no. It's like within the verifiable credentials world, there's this idea that this is sort of like this could be like, oh, here we go. Yay. Hold on, let me do this. Okay, cool. And here's the actual transaction if it loads. But yeah, so within sort of the verifiable credentials world, there's this notion of like the proof. There's many types of proofs, and they can be kind of like registered so that if you as a verifier receive a proof with a certain type, you can then go like essentially look up how to do the verification. So in the case where you'd receive this particular type, you'd then know, oh, I can verify this. I would be verifying this as via zero knowledge. Oh, yeah, so it's not working, but okay, cool. I think that's it.